The Heisenberg Uncertainty Principle, invented by Werner Heisenberg, is a foundational part of physics. The principle expressed as delta x times delta p is greater than h over 4 pi, in which delta equals uncertainty of an object, x equals position, and p is momentum. H is Planck's constant, a small amount but important number. The ratio is always true for particles, and as such, the principle can be used to explain several phenomena. One of the more notable applications of this is in electrons. In conventional physics, it was thought that electrons might eventually spiral into the nucleus. Imagine it like putting a marble into a funnel. It loops inward until it hits the center. The same was assumed to happen in atoms. However, the uncertainty principle provides a different mechanic. Since the ratio must always be true, then when one of the factors gets smaller, the other gets bigger. In context of electrons, when they get close to the center, the uncertainty of their position decreases. But as this happens, there's a small chance that the electron's speed could increase, making it zoom out. Another application of the principle is when radioactive elements decay. This means that 4 particles found in the center of the atom, the nucleus, leave the atom. The particles in question are 2 positive protons and 2 neutrally charged neutrons. When conventional physics won't allow this to happen, the uncertainty principle allows for this. Since the particles in question are found in the nucleus, we know their momentum to a small uncertainty, making the position of the particles highly unknown. This gives a minuscule chance of going outside the nucleus. When this happens, the element decays into a new element. Our final application, quantum tunneling, is one of the more interesting applications of the uncertainty principle. However, there is no physical digging involved. Quantum tunneling is when a particle, usually a light particle, also called a photon, goes through a barrier that normally wouldn't go through. This is based on the uncertainty principle, since it allows that there be a small chance that the photon can travel through the barrier. The application of the uncertainty principle were so revolutionary that they forever attached the name Heisenberg to this principle.